Hello, space enthusiasts, and welcome to another episode of Astronomy Daily. I'm your host, Anna, and we've assembled quite an array of stories for you today, covering some incredible new discoveries and developments in the world of astronomy and space exploration. From an extraordinary light show at the heart of our galaxy, to groundbreaking observations of distant exoplanets, revolutionary breakthroughs in space technology, and even an update to some potentially concerning asteroid news, we'll be covering it all. Today's journey will take us from the supermassive black hole at the center of our Milky Way to the far reaches of space, where we're discovering new possibilities for life around dead stars. We'll also look at some exciting developments in international space collaboration and witness history being made with synchronized rocket launches. So strap in and get ready for a fascinating exploration of the latest developments in space science and astronomy. Let's go. The James Webb Space Telescope has given us an unprecedented view of Sagittarius A star, the supermassive black hole lurking at the center of our Milky Way galaxy. And what it's revealed is nothing short of spectacular, an endless cosmic light show that challenges our understanding of these mysterious cosmic objects. Throughout an entire year of observations, scientists have witnessed Sagittarius A star constantly emitting streams of flares. These aren't just occasional bursts. We're seeing 5 to 6 major flares every single day, each one unique in its brightness and duration. Some flares shine blindingly bright but only last moments, while others maintain a fainter glow that persists for months. What makes this discovery particularly fascinating is the seemingly random nature of these emissions. Dr. Farhad Yousefzada from Northwestern University, who led the study, describes it as a constantly changing, bubbling brightness that suddenly erupts in spectacular bursts before calming down again. There's no discernible pattern. Each observation reveals something new and unexpected. The team believes these flares might be generated by two different processes. The shorter, fainter flickers likely come from turbulent fluctuations in the black hole's accretion disk, the ring of matter swirling around it. Think of it like solar flares on our sun, but in a much more extreme environment. The larger, brighter flares, on the other hand, might result from colliding magnetic fields releasing accelerated particles. This constant activity shows us that supermassive black holes are far from the passive cosmic vacuum cleaners we once imagined them to be. Instead, they're dynamic objects that actively interact with and influence their surroundings in ways we're only beginning to understand. Looking ahead, scientists hope to conduct even longer, uninterrupted observations of Sagittarius A star to uncover more details about these mysterious flares and perhaps finally determine if there's any pattern to this cosmic light show. These observations could revolutionize our understanding of how supermassive black holes behave and influence their galactic neighborhoods. Next on today's agenda, in a remarkable display of modern spaceflight capabilities, Rocket Lab and SpaceX conducted near-simultaneous launches just minutes apart, each achieving significant milestones in their respective missions. Rocket Lab's Electron rocket took off from New Zealand at 6:17 p.m. Eastern, carrying Black Sky's first next-generation imaging satellite to orbit. This Gen 3 satellite represents a major advancement in Earth observation technology, capable of capturing images at an impressive 35-centimeter resolution and even seeing through smoke and haze using shortwave infrared. Just 4 minutes later, SpaceX launched their Falcon 9 rocket from Cape Canaveral, deploying 23 Starlink satellites. But what made this launch particularly noteworthy was its groundbreaking landing. For the first time in SpaceX's history, the Falcon 9's first stage booster touched down on a drone ship in Bahamian waters, marking their first landing in another country's territory. This new landing zone isn't just about adding another pin to SpaceX's map. It opens up entirely new trajectory options for launches from Florida, particularly beneficial for missions headed to polar orbits. It also provides a valuable alternative during winter months when weather conditions in the North Atlantic can be challenging for booster recovery. The Bahamas Deputy Prime Minister, Isaac Chester Cooper, highlighted the significance of this achievement for his nation, seeing it as an opportunity to establish a foothold in the aerospace industry while potentially boosting both educational opportunities and tourism. Despite some initial concerns about safety and environmental impact, Cooper emphasized that extensive due diligence was done to ensure a successful first international landing. These launches represent the continuing evolution of commercial spaceflight, with both companies pushing the boundaries of what's possible. For Rocket Lab, this marks their 60th Electron mission, while SpaceX continues their ambitious pace toward their goal of up to 180 Falcon launches this year. Moving on to exciting developments in international space cooperation, the United States and India are strengthening their partnership in space innovation through a new initiative called Indus Innovation. This program aims to create an innovation bridge between the two nations, focusing on space technology alongside other emerging fields. The partnership builds on the success of IndusX, established in 2023 to promote cooperation between the defense industries of both countries. We've already seen promising results from this collaboration, with the Air Force Research Laboratory forming agreements with Indian startups on space domain awareness and Earth observation technologies. One of the most tangible outcomes of this partnership will be the upcoming flight of an Indian astronaut aboard the AX-4 private mission to the International Space Station. This historic mission, scheduled for this spring in the U.S., represents a significant milestone in the growing collaboration between these two spacefaring nations. The countries are also working together on the NASA ISRO Synthetic Aperture Radar mission, known as NISAR. While this Earth science mission has faced some delays due to technical challenges, it demonstrates the commitment of both nations to joint scientific endeavors. Looking ahead, the partnership will expand into several new areas, including long-duration human spaceflight missions, spaceflight safety, and emerging fields like planetary protection. There's also a strong focus on commercial space activities, ranging from launch services to space tourism and manufacturing. This enhanced collaboration between the United States and India marks a significant step forward in international space cooperation, potentially accelerating technological advancement and scientific discovery in both nations. Next up on today's story list. In a groundbreaking achievement, astronomers have created the first ever three-dimensional map of an exoplanet's atmosphere, giving us an unprecedented look at the weather patterns of a distant world. Using the European Southern Observatory's Very Large Telescope, scientists have peered deep into the atmosphere of WASP 121b, also known as Tylos, an ultra-hot Jupiter located about 900 light-years away. What they found is simply astounding. Imagine a world where iron and titanium are carried by extreme winds across alien skies, creating weather patterns unlike anything we've seen before. The planet's jet streams form a climate system that makes our most violent hurricanes look like gentle breezes in comparison. This remarkable gas giant completes an orbit around its star in just 30 Earth hours, resulting in one side being permanently exposed to its star's intense heat, while the other remains relatively cooler. The team discovered a complex system of winds operating at different layers in the atmosphere, with a powerful jet stream rotating material around the planet's equator. The observations revealed three distinct atmospheric layers, each with its own unique characteristics. At the deepest level, they found iron winds, followed by an incredibly fast jet stream containing sodium, and finally, an upper layer of hydrogen winds. Perhaps most surprisingly, they also detected titanium lurking just below the jet stream, an element that had previously gone unnoticed in earlier studies of the planet. This breakthrough wasn't just about mapping weather patterns. It demonstrates our growing ability to study distant worlds in incredible detail. Dr. Julia Seidel, who led the study, noted that this planet's atmosphere behaves in ways that challenge our understanding of how weather works, not just on Earth, but on all planets. The implications of this discovery extend far beyond this single planet. These new techniques and insights will help us better understand other exoplanets, potentially including those more similar to Earth, as we continue our search for worlds that might harbor life. Now, a little update for you on a story we, and most of the world media, it would seem, have been following. Recent observations of asteroid 2024 YR4 have raised concerns among astronomers as NASA has upgraded the risk assessment for a potential Earth impact in 2032. The latest calculations now show a 3.1% chance of collision, or approximately a 1 in 32 probability, the highest odds yet recorded for this space rock. The asteroid, discovered just this past December, has been under intense scrutiny from telescopes and space agencies worldwide. As more data comes in about its precise orbital path, astronomers have been able to refine their calculations, leading to a steady increase in the estimated probability of impact. The odds have climbed from an initial 1 in 83 chance to the current 1 in 32 risk, Measuring between 40 and 90 meters wide, this asteroid packs quite a punch. Should it impact Earth, it could release energy equivalent to 7.7 megatons of TNT, enough power to devastate a city. However, experts caution that the increasing odds don't necessarily mean a collision is more likely to occur. Time is becoming a critical factor in assessing the true risk. The asteroid will pass behind the Sun in April, making it impossible for most Earth-based telescopes to track it. This creates a significant gap in our ability to refine predictions until it becomes visible again in 2028. In the meantime, astronomers are searching through historical data for any previously overlooked observations that might help better define its trajectory. The James Webb Space Telescope is expected to gather crucial information about the asteroid's size and composition in the coming months. This data will be vital in understanding whether it could survive Earth's atmosphere intact and what kind of impact it might cause. The asteroid's composition, whether it's primarily rocky or rich in iron, could make a significant difference in its potential impact effects. While these odds are concerning, it's important to note that we have several years to continue monitoring and analyzing this object, and our predictions will become more refined as we gather additional data. Finally today, scientists have made an intriguing discovery that challenges our traditional understanding of where life might exist in the universe. New research from the University of California, Irvine suggests that planets orbiting white dwarf stars could potentially harbor life, opening up exciting new possibilities in our search for extraterrestrial life. While white dwarfs have typically been overlooked as potential hosts for habitable worlds due to their lack of active fusion, sophisticated climate models are now telling a different story. These dying stars, of which there are an estimated 10 billion in our galaxy alone, might actually provide more favorable conditions for life than previously thought. The study used advanced 3D global climate models to compare planets orbiting white dwarfs with those circling stars similar to our Sun. Surprisingly, they found that planets around white dwarfs could be significantly warmer than their counterparts, despite receiving similar energy levels from their host stars. One key factor is the unique orbital characteristics of these systems. Because a white dwarf's habitable zone is much closer to the star, planets in this region complete their orbits much more quickly, rotating once every 10 hours compared to the 155-day rotation period of planets around Sun-like stars. This rapid rotation creates distinctive climate patterns that could actually benefit potential life. Even though these planets would likely be tidally locked, with one side perpetually facing their star, their ultra-fast rotation helps distribute heat more effectively around the planet. This prevents the buildup of thick cloud cover on the day side, allowing the planet to retain more heat and maintain more habitable conditions across its surface. This research suggests we might need to broaden our search for life beyond traditional targets. As we continue to enhance our observational capabilities, particularly with tools like the James Webb Space Telescope, these previously dismissed stellar remnants could become promising new frontiers in our quest to find life beyond Earth. That wraps up another fascinating journey through the cosmos with Astronomy Daily. Thank you for joining me today as we explored everything from spectacular black hole light shows to groundbreaking space partnerships and the possibility of life around dying stars. I've been your host, Anna, taking you through these incredible discoveries that continue to reshape our understanding of the universe. If you've enjoyed today's episode and want to stay up to date with the latest developments in space and astronomy, make sure to follow Astronomy Daily wherever you get your podcasts. You can find us on all major platforms, including Spotify, Apple Podcasts, YouTube, and iHeartRadio. By subscribing, you'll never miss an episode, and you'll be the first to hear about breaking news from the frontiers of space exploration. Until next time, keep looking up and wondering about the mysteries that await us among the stars. See you tomorrow.